Hey guys, welcome to this video about significant digits. Let's start with the definition. Sig digs are all the digits in a measurement that are known with certainty and the one and only one digit that is estimated. We pay attention to sig digs really for two reasons. One reason is so that every reader of a piece of data will interpret it in the way the recorder intended. And the second reason that we pay attention to sig digs is so that we know where to round off our answer when we're doing calculations with those measurements. Let's start by taking a look at a volume measurement. So let's say this is a graduated cylinder, and you clearly have some liquid in that measuring device. The meniscus, remember, is this curved upper surface. And just a side note, remember that you're always going to read a meniscus, not here at the top of the curve, not kind of in the middle of the curve, but at the very bottom of that curve. So I'm going to put my arrow right here. All right, this particular graduated cylinder has numbered markings at 600 and 650, but in addition there are other graduations, so I can clearly say this is 610, 620, 630, 640, 650. Now, some people might read the bottom of the meniscus as 635. So let's say that is one person's best reading, 635 milliliters. But their lab partner may come along and say, you know, I don't think that meniscus is right in the middle between 630 and 640, so I'm going to call it 634 milliliters. And yet another person might come along and say, it looks to me like 633 milliliters. Okay, all of those measurements are valid because in each case, all of the people doing the measuring were certain of 630. So there were two digits that were certain. And then this last digit that they recorded, the ones place in this case, was the one that was being estimated. So that's our estimated digit. And recall that sig digs are all the digits in a measurement that are known with certainty and the one that is estimated. So each of these measurements has a total of 3 sig digs. Now, if we can look at another volume measuring instrument, this is another graduated cylinder, but the markings are slightly different on this one. We have numbered graduations at 630 and 635, with these additional markings in between. So we're going to say this is 631, 632, 633, 634, and 635. In this case, we are all certain that the meniscus is above the 634 line, but not to the 635. Again, if I'm reading at the bottom of the meniscus, right here, and I'm going to say, I'm going to put my arrow right here. Okay, so some might call that 634 and just a hair above the line, 634.1 milliliters. Someone else may read that as just, a little bit more than a hair above. They might call it 634.2 milliliters. And someone else might come along and say, I don't know, that bottom of the meniscus looks to me like it is right on the 634 line, in which case they are certain of 634 and they're estimating 0/10. Again, all 3 of these measurements are perfectly valid, and all 3 of these measurements have 1, 2, 3 certain digits and 1 final digit that is estimated. 3 that are certain plus the 1 that is estimated gives us 4 sig digs with this particular measuring device. All right, now let's focus on the second reason for why do we pay attention to SIGDIGs, and that is going to be very useful to us as we go through the year. When we do calculations with measurements in the lab or in practice problems, when we do our calculation, our calculator often will give us a huge big number, and we need to know where it's appropriate to round that off. So let's consider yet another problem. Here we have a thick liquid whose mass has been measured at 48.22 grams. So this is telling me that the measuring device for mass, the balance, was probably pretty precise. It looks like it was a centigram balance. Then the liquid was poured into a volume measuring device. This looks to me like it's a beaker, which, by the way, is not a good device to use for measuring volume. But because it only has a mark at 30 milliliters and then one at 40, the best we can do is to estimate, and we're going to say we're estimating it to be a 35 milliliter volume. Someone else might say 36, someone else might say 34. We're asked to find the liquid's density, and density is mass divided by volume. So we take our fairly precise mass, 48.22 grams, and we divide it by 35 milliliters. Now, when I plug those two numbers into my calculator and divide, this is what my calculator gives me. It would not, however, be appropriate to record that for your answer, and I think you know that intuitively. This has way too much precision, given that one of my measurements was not very precise. So we have a rule when we are calculating with measurements, and the calculations for SIGDIGs tells us that if measurements are going to be multiplied or divided, then our answers, SIGDIGs, will be limited to the measurement with the fewest SIGDIGs. Back to my two measurements. My mass had 4 SIGDIGs, but my volume had only 2 SIGDIGs. And therefore, this very precise answer has to be rounded to 2 SIGDIGs. So I look at my calculator answer. Here's 2 SIGDIGs. Now you always want to peek at the next digit, and if it is 5 or larger, it's going to cause you to round up. So the appropriate answer here is 1.4 grams per milliliter for the density. So again, when you are multiplying or dividing, your answers, SIGDIGs, must be limited. You're going to do some rounding, so that you come up with an answer whose SIGDIGs match the measurement with the fewest. All right, so these significant digits are very important in the scientific world, and the scientific community has come up with some agreed upon rules or conventions. The first rule tells us that any measurement that includes non-zero digits, I mean 1, 2, 3, 4, 5, 6, 7, 8, 9. Those digits are always significant. The zeros, however, give us a little bit of confusion. Zeros are sometimes significant, sometimes yes, sometimes no. So we have 3 guidelines to help us. Zeros at the beginning of a number are never significant. Here's an example. If your mass reading is 0.053, these zeros at the front, sometimes called leading zeros, are never significant. Now, please don't misunderstand me. I'm not saying that they're not important. They absolutely are important. This very first 0 is helpful. It just helps us see the decimal point there. And then this one is a placeholder. It's telling us we have 0/10. You can't leave it out. It's very important. It just doesn't count as a significant digit. This measurement has 2 SIGDIGs. Next, Zeros in the middle of a number, we sometimes call them sandwiched zeros. Those are always significant. So example, 208 feet is the measurement. Okay, this zero sandwiched in between non-zeros, that zero is significant and they are always significant, these sandwiched zeros. 3 sig digs in this measurement. Certain, certain, and the ones place in this case is the estimated digit. All right, lastly, we have zeros that come at the end of a number. We sometimes refer to these as trailing zeros. So the sometimes means sometimes they will count as sig digs, sometimes they will not. Here is how we decide. If the number has a decimal point, zeros at the end of that number are significant. For example, the measurement 41.50 milliliters. That number has a decimal point, so the zeros at the end, the trailing zeros, will count in this case, 4 sig digs. Some numbers, however, have trailing zeros and the number does not have a decimal point. For example, 68,200 nanograms. This measurement has trailing zeros, but notice the number does not have a decimal point. This, by the way, is a comma. If this number does not have a decimal point, then these trailing zeros are not significant. This particular measurement has only 3 sig digs. This is telling the reader that you were certain of 68,000 and you're guessing 200. Someone else might read it 68,300, 68,100. Now, sometimes you want to tell the reader, you know what, I actually was certain of that 200 and I am estimating 0.10s. That's tricky, but you can always record the number using scientific notation, 6.820. That number has a decimal. This trailing zero counts. This is 4 sig digs. And if you write it like this value is exactly the same as this one, but this form is telling the reader, I am telling you I had 4 sig digs. All right, guys, so these rules are going to be your guidance when you are looking at numbers and trying to decide how many sig digs each measurement has. So keep this handy. And then I want to wrap up with one more rule, which is actually about decimal points and not sig digs. This happens when you are adding or subtracting measurements. So let's suppose that you had some silt and some sand that you needed to add together for a total mass. You massed the silt on a very precise milligram balance, and then you had some cheesy, imprecise balance that you used to measure the sand. When you add these two numbers on your calculator, this is what you're going to get. But this is not an appropriate answer. So our rules when we're adding or subtracting tell us, don't look at the sig digs, but instead look at the decimal places. This first number has 3 decimal places, but our second number has 0, which means our final answer has to be limited to 0 decimal places. And we're going to take this calculator answer and round it to 0 decimal places. Whoops, don't forget to peek. This number is greater than 5, so it's going to cause me to round up. And my final answer, 43. Okay, that was a lot about decimal places, sig digs, calculations. So we will continue to talk about this and use it throughout the year. Thanks, guys.